Hi guys, welcome to my YouTube channel. If you're a JAM aspirant or a JUPEP student presently, this video will be of importance to you. This is a continuation from where we stopped on our video on scalar and vector quantity. Uh, Please don't forget to like, subscribe, and comment to this video. This video will be of what great importance to you. Continue from where we stopped from our scalar and vector quantity video. Now today we are talking about the quadrants and vector components. Last video I talked about the vector component that we have a y-axis, right, and a x-axis. That means we have a what an horizontal component, which is our what our x component, and also we have our y component, right? So in order for you to solve a vector, to know the direction in which a particular vector goes to, you must know how to what to measure this vector, right? So to measure vector, when measuring vector, we always measure from this positive y-axis. We always measure from this place. That means this place is our e0, this place is our 90, 180, and what 180 and what 270, right? We measure from what positive x-axis, like this, like this, like this, to this place. That's how what we measure in what in vector quantity. But in bearing, in mass, they always measure from what this positive y-axis clockwise. But in vector quantity, we measured in what from positive x-axis anti-clockwise. That's how we measure vector and know the direction in which different vectors move to. So this is our what our first what quadrant. This is our second quadrant. This is our third quadrant, and what our fourth quadrant. So to measure the if you are given a vector, let's say in the first quadrant, that means you'll be given a value that has what a positive, that is in a positive x-axis, and a what and in positive y-axis. So if you have a vector that lies in this quadrant, positive x and what positive what y, that means your quadrant falls in this place, which is 90, right? And if you want to measure it, you measure it from what from positive x-axis to what anti-clockwise. That's what for first quadrant. For second quadrant, you will still measure from what from the positive x-axis. You can be given an angle between this place, right? You are given an angle between this place. So if you want to measure the vector, you start from from here. From here to here is 90 plus the angle that is in this place. That will give you what your your answer. That means for this second quadrant, for to be in second quadrant, you be in what negative. You given negative x. That means your value is in negative x-axis and positive y-axis, right? So if you want to measure your the direction of your of your vector, let's say this direction of it's being represented by by phi. That means the direction of your vector is what that's 180 minus theta. 180 minus theta. Okay, let's say we are given 60 in this place. That's 60. If we measure from here to this place, that's 60 plus 180. 60 plus 90. 60 plus 90 will give you what? That's 150. Right? 50 plus 90 will give you 150. Here, to use this phi, this your angle is always what? To the horizontal, right? You are given 60 degree. If you want to measure it from this place, you measure it from here, from this place. That's from here to here is 90 plus this place, which is what? 150. That's a what? Is your angle phi. But if you want to use this formula, this angle is always what? To the horizontal. That means 60 minus 90. Since this place is angle 90, that's 30. That means here will be what? 30. That means your angle phi is what? 180 minus 30, which is what? 150. It's still the same thing. So for the what? For the third quadrant, that means your x-axis is what? Negative, and your y-axis is what? Negative. So the angle phi in between them will be what? Phi plus 180. Theta plus 180. Right? That is how you get your what? Your angle in this place. So to get your angle in the fourth quadrant, that means your angle is in between positive x-axis and what? And negative y-axis. Your angle phi will be 360 minus theta. And remember, this theta is what? To the what? Horizontal. The angle that your resultant vector make with the x-axis, not with the y-axis. That is what? Your theta. This how you resolve your what? Your vertical component or horizontal component into what? Into quadrants, so that you can get the what? The direction of what? Of the vector. Now let's move to what? To resultant of two or more vector. Now the resultant of two or more vector. If you are having two or more vector, what are the methods you can use to resolve this vector? We have three major methods in resolving this vector. Number one is what? The graphical method. Number two, we have a parallelogram method. And third, we have what? Component or vectorial method. So this is what the three methods you can use to resolve two or more vectors into what? Two or more vectors, so that you can get your resultant vector. Like I said, resultant vector, they are what? Combination of many vectors to become a one vector. So if you have vector A, vector B, vector C, if you add all of them together, it will give you a resultant vector. This resultant vector will act as individual vector. That means the magnitude and the direction of all these vectors, this is what this resultant vector is having. So graphical method, that means the use of graph, right? You can use graph to represent vector. So graph, it has y component, horizontal component, and you'll be using points to connect what? The vector together. Let's say we are given vector, let's say resultant vector of A plus B plus C plus D, right? In graphical method, let's say we want to represent these four in graphical method. Let's say we have something like this. This is the beginning. A, B, C, D, or something like this. So this graphical method requires the use of graph. You use graph to what? To get your what? Answer. So how would you know the resultant vector here now? This place, let's say this is our starting point. We call this place tail. This is our tail. This is our head. Right? This tail, is always the starting point, is pointing towards the direction. Head. Right? This is another thing. You can see this represents our what? Vector A. This vector A, this vector B, this vector C, and this vector D. Why this one is what our resultant. So the vector, they are what from head to tail. That's head and tail, head and tail, head and tail. But when it comes to what to resultant, you saw what head and tail and tail. That means the combination of all these vectors, they are being represented by only this what the resultant, which is what head and what and tail. And for you to get this graphical method, you must use what graph. This word accuracy. So let's move to the next one, which is what the parallelogram method. So parallelogram method. So we have that parallelogram law of vector. So this is a parallelogram. These are the side, the diagonal side and the horizontal side. So this diagonal side, they are always equal. This place is equal to this place. This place also is equal to this place. So we now draw a resultant here. So what parallelogram law is saying is that if this one is vector A and this one is what vector B, the resultant vector is drawn from a common point between this A and B, right? And this resultant is representing both the magnitude and the direction of these two vectors, which is A and B. So parallelogram law of vectors state that the resultant of a vector that is drawn between the common point between two vectors A and B are represented by what? Both the magnitude and direction, and this resultant, they act as a what? As a unit. They have the what? The effect of this vector A and what? And vector B. Let's write. So parallelogram law of vector states that the resultant vector is represented by a line drawn from a common point between vector A and vector B, and this line is represented by both magnitude and direction. So you don't need to cram, just know this diagram and know that this resultant that is drawn between these two common points between this A and B, they are what? They are being represented by what? The magnitude and direction of the two, and the resultant has only as the effect of the both vector. So let's look at it critically. Like I said before, let's say this place is A. The distance between this place is equal to this distance between this place. We can say this place is also A, right? And between this A and B, we have what? We have an angle there. So how can you able to calculate this resultant? According to cosine rule, we have sine and cosine rule, but in this scenario, we are going to use cosine rule. What does cosine rule say? Cosine rule, you can only apply cosine rule when you are given two sides of a what? Of a triangle. Two sides of a triangle and one included angle. When I say included angle, that means the angle that is joining the two sides together. So if you are given two sides and one included angle, you can use cosine rule. Or when you are given three sides, you are given this side, this side, this side, you are not given the angle, you can use cosine rule to what? To solve the problem. What is cosine rule? Cosine rule, that's cosine rule. For this diagram, the cosine rule is what? R square over what? A square multiplied by what? B square minus 2ab cos theta. That is what cosine rule. If you want to get this resultant, this is what you use to get the what? The cosine rule. So let's evaluate it. We can have R is equal to what? Open bracket a square b square minus 2ab cos theta. From here, you can be able to get your what? Your resultant of this vector. Okay. Let's talk about the third method for getting the resultant. That's what the vectorial method. That's what the vectorial, or the what? Or the component vector. This vectorial method or component method, you are what? You are resolving the vector into what? Vertical and horizontal components. For example, you are given more than one vector. Let's say you are given A, this vector A, and in A vector you are given let's say as ax I plus a y j plus a z k, and you are given another vector B as b I plus b y j plus b y k. Like I said before, all these I, j, k, they are just representing what? The direction. So if you are given this type of question, right, how will you resolve it? This is a x component, y component, z component. So if you want to resolve this vector, what are you going to do? That means you are going to what? To resolve it one by one. That means you want to get the resultant of these two vector. You are going to resolve this one separately, and this one separately. Okay, that's how you resolve it. So you want to get the resultant. Let's say a plus b. Like I said, the resultant is what? The addition of these two vectors, which will give us the resultant, right? That resultant will be what? We might this one and this one together. That's a x, ax, ax, bx, open bracket, I, here, y, we have plus ay, by, j, plus az, bz, k. You see, you have resolved it into what? S component, Y component, and Z component. That is a what? A vectorial what? Method of vector. If you have to get the resultant, how will you get it? The resultant of this vector, which is R, will be what? This is the resultant. Magnitude, John. Magnitude. So the magnitude will be what? R is equal to what? Open bracket, what? Ax bx square plus ay by j plus az bz k square. So if you want to get the magnitude, this is how you will get it. So let's move on. Let's do the subtraction, addition, multiplication of vector. Addition, subtraction, and multiplication of vector. So addition of vector, that's what we just did when we are getting the resultant. Let's do subtraction of vector. Subtraction of what? Vector. So you are given vector A and vector B, and you are asked to subtract. So vector A, you are given ax, let's say, plus ayj, b ax, ay, by John, by plus so you are given this, and you are asked what? To subtract. How are you going to do it? That means A minus B will now give you what? That means this one will go together, this one will go together. That means this one and this one will go. That means we have something like ax bx I minus ay by j. This is what? Subtraction of what? Of vector. This is how you subtract. So this is how you subtract. You just do this as a component vector. This one will go with this one. This one will go to the other one, and you get your answer. So let's do multiplication of vector. Vectors. So multiplication of vector. So if you are multiplying vector, we have two multiplication of vector. We have what? Scalar dot product and what? Vector cross product. So we have scalar or dot product. We also have what? Cross product in vector. So like I said, the scalar quantity is what? If you do the product of scalar dot product, the product will give you what? A scalar quantity. Why? In this cross product, if you multiply in cross product, you are going to have a what? A vector quantity. That is what? The difference. And for this scalar dot, we only use dots for it. While for vector, for cross product, we use times. So for example, you are given something like this. You are given A dot B. You are given A to be what? AX I, let's say, plus AYJ. B is equal to BX I plus BYG. And you are asked what? To do product of the two, that's dot product. We have something like this. This one, we go with this one. We have something like this one with time, this one times this one. We give you what? And like I said before, if you do the product of I times I, it will give you 1. That means if this one multiplied by this one, this is what you get. That's X and what? B. That's plus that in this case. And this case, if J times J, you also get 1. Your final answer will what? Will be scalar. Right? But if it is a dot product, your answer will not be scalar. Your answer, if it's a cross product, your answer will what? Will be vector quantity. Why? Because the direction are still there, right? The direction are still there. So from this place now, you may ask to find the angle between this vector. So to find the angle between this vector, there's a particular formula. B is equal to what? B cos theta. That's what? A dot B equal to the magnitude of A times the magnitude of B cos theta. So this is what the formula to get the angle between what? The dot product of what? Of two vectors. So they can ask you in your exam that at what point is the dot product of a vector is maximum, or at what point is dot product of a vector is what? Is minimum. So look at this formula. A dot B equal to A B cos theta. So assuming this cos is what? Is 90. What's cos 90? Cos 90 is 0. While cos 0 is what? Is 1. So at what? Angle 90, that is when these vectors are what? Are parallel. Are what? Are perpendicular. When these vectors are perpendicular, the what? The dot product of this vector, they are what? They are minimum, because it's what? Is 0. So A dot B at angle 90 is 0 when they are what? Perpendicular. But when A dot B is 0, that means they are parallel. That means A, the cross product will be what? Will be this at angle 90 degree, at angle 0 degree, will be what? Will be maximum. That's what? This place is what? Is max. This place is what? Minimum. So they can ask you at what point is the dot product of A and B minimum. It's minimum as what? Angle 90, and it is maximum at what? Angle 0 degrees. So this is how you will get your what? Your dot product. Okay, let's move to what? To cross product. Wow. Now cross product. So cross product, like I said, cross product always give you what a vector what quantity. Let's say we have a equal to what ax I plus a yj plus a y k. Let's say b, we have bxi plus byj plus bzk. We have c again, that's cxi plus cyj plus czk. Okay, no, let's go with two first. Let's go with two first. So if we are asked to find the cross product of these two, let's say a cross b, right? How will you find it? To find a cross b, we are going to use matrix, right? Matrix. That's a cross b. We give us something like this. We now say this place is what? This place is I. This place is what? J. This place is what? Is K. Right? For A, you now say A X, A Y, A Z. This B X, B Y, and what? And B Z. Now, how are we going to solve it? This represents y-axis, x-axis, y-axis, and what? Z-axis. So to solve this, we use matrix. So in matrix, we have something that is called a cofactor sign convention. A cofactor sign convention means that every rows and column has their own cofactors, and that cofactor has a sign that it denotes. For example, this is what? This is a row, this is a row, this is a row, this is a column. This is what? First row. This I is located in what? The first row and what? And first column. First row, first row and first column. J, that's first row and second column. K, first row and third column. So in first row and first column, the sign convention of a cofactor is what? Is positive. For first row and second column, negative. This place positive too. So that's how you solve it. So now let's solve. So A times B will now be what? For I, let's solve for I, which is what? Positive. The positive will be here. So what are we going to do? We have I is in what? First row and first column. You now cancel the first row and first column. What does it remain? It remains this place. So that's what we write here. That's AY, that's BY, AZ, and what? BZ. Minus J. Let's clean this place. J is in what? First row and what? Second column. We cancel the first row and the second column. What remain? Remain this one and this place. That's what we write. AX and what? BX, AZ and what? BZ. Y plus K plus K. K is in what? First row and what? And third column. What remain? It remain only this place. That's what we write in. AX, AY, that's BX, and what? BY. So let's continue. Now, this is the final round. So A plus B will now give you what? Mind you, you will what? You will turn from what? From what? The left hand side to the right. That means this place multiplied by this place, this one multiplied by this one. That means a y multiplied by b z minus a z multiplied by what? B y. They now give you what? Your I minus the second one. You do it like that too. That's this one multiplied by this one, which is what? Ax times bz minus az bx. That'll give you your what? Your j. Why the what? Why the last one, which is plus, open bracket, ax times by minus ay times bx, which is what? Which is k. So from here we can get our final answer. If we have value for a, we multiply and do our final answer, and we get our what? A what? Cross b. So this a cross b also have a what? If we want to get the angle between this vector, we can say that a cross b, the magnitude of a cross b is equal to what? A b sine theta. But in that dot product is what? Is cos theta. But here is what? Sine theta. So they can also ask you the question that they asked in that place: at what point is the magnitude of a cross b is maximum and what are minimum? We all know that sine 90 is what? Is 1, while sine is 0 is what? Is 0. Right? Sine 90 is 1, while sine is 0 is 0. So the magnitude of a cross b is what? Is max at what? When the angle is perpendicular, that's at angle 90, while a cross b is minimum at angle of 0 degrees. Now this is what for what? Cross product. Now we have property of cross product. We have some property of cross product. The sign convection that you will see in a cross product when you are working on cross product. So we have properties of cross product. So in cross product, if you have something like this, if you have a cross b dot c is also equal to what? It's also equal to what? C dot a cross b. They are equal. In some question, you might give this type of what? Question. So we know that they are both what? Equal. In some question, they can give you and say that a cross b, they can say a cross b cross c. So a cross open bracket b cross c. How are you going to solve this? You now say a, you pick it from this place, and the last one dot c, b minus a dot b C. This is how you are going to what? To resolve it. You can also be given, you can also say, be given, and you are given question like this, that's B cross C cross A. You see, this one and this one is almost the same, but they they just interswitch them together. So in this particular one, it's different from this one. This one now, you are going to choose from this place. Let's see. Let me just put it like this: A cross B cross C. You understand? Let's put it like this. So, like this now. How will you start it? You start it exactly like this one. This one dot C, right? B minus, this way it will be different. Minus C dot B A. So this is what the sign convention. When you are solving it, you are given this type of question, this is how you solve it. And let's go back to this. So, and also if you are given something like this, A cross B dot C, you know that this is how you solve it. You now solve it into what? Matrix, which is what? A. Please, this place will represent A, right? And this A has Y component, has X component, Y component, and what? Z component. This B has what? X component, Y component, and Z component. While C has X component, Y component, and Z component. And you know that this one is I, this one is J, this one is what? K. Now you can now use the sign convention I told you. This place is what? Positive, negative, and what? Positive. And what? You will solve it the way I solved what? The other one. So thank you for listening to this video. God will help you. Goodbye.